This is page 14 from the packet, the introduction to understanding proportional relationships. Number 1, Josie is making pizza dough. Complete the double number line by filling in the missing values. Then write an equation that models the relationship between the total numbers of flour, C, and the number of batches, N. C, N. Well, I'm going to start with batches because it's a little bit easier to understand. I'm trying to figure out each time what happens as I go to the right on this double number line with tick marks. Well, it looks like this goes up one and this goes up another one. So you're right if you thought that the blank right here was 3 because it needs to go up another one. And then this one needs to be 4. It's slightly harder to see what's happening on the top, but again, I want to think about each of these tick marks is evenly spaced. So I want to think about, okay, what happens as we go up one right here? Well, it looks like it's adding 3/4 each time. Now, because 3/4 is a fraction that always panics people, don't panic. We're going to write it both as a improper fraction and as a mixed number. So if I add 3/4 to 3/4, remember we just add the numerator. So that's the same as 6/4. It's fine to leave it as that. If I want to change that to a mixed number, we divide. 6 divided by 4 is 1. And we have a remainder of 2. So that becomes our new numerator. So this is 1 and 2/4. Okay, I'm going to keep 6/4 for the purposes of just adding. Another, if I add 3 again, I'm going to end up with 9/4. Well, if I want to change that back into a mixed number, I'm going to divide. 9 divided by 4 is 2, and we have it's 8, so there's a remainder of 1. And then I keep the denominator the same. Okay, if I add 3 again to 9/4, I'm going to end up with 12/4. Well, when I divide 12 by 4, I just get 3, so there's no remainder. They've just written that as a whole number. And then if I add 3 again, I'm going to end up, or add 3/4 again, I'm going to end up with 3 3/4. Well, we want to think about, for this equation, we're going to find C. So C equals, and I'm going to think about what is the constant of proportionality. Well, the constant of proportionality is how much are we adding in the top. As we go up one more batch, how much flour are we adding? Well, we're adding 3/4 of a cup for each batch that we make. So that's my constant of proportionality, and then N goes right here. That's the equation. Okay, let's think about the same thing in a table for number 2. Lily bought each of her friends a pair of colorful socks that cost $5.50. Complete the table to show how much Lily paid to buy different numbers of socks. Then write an equation that shows the total cost C for P pairs of socks. Well, it tells us in the information that for one pair of socks, she paid $5.50. And it makes sense that as she bought 2 pairs of socks, she's adding $5.50 again. So she's going to end up with $11 for 2 pairs of socks. To buy 3 pairs of socks, she's adding $5.50 again. So she is going to end up paying $16.50. And when she buys 4 socks, she's adding $5.50 again. So $16.50 plus $5.50 is going to give us $22. You guys are right. Okay, so let's think about another way. I could definitely add $5.50 again. But what is a faster way maybe to get to 5 without the cost for 5 socks if we didn't do this whole table? You are right if you thought, oh, Miss Harris, I can just take $5.50 and multiply it by however many pairs of socks I'm getting. So in this case, 5. And end up with the cost, which for 5 pairs of socks is $27.50. Well, thinking about how we're multiplying by that to find the cost, or C, for pairs of socks, this is going to be C, this is going to be P. You were right that we're multiplying $5.50 by P, however many pairs of socks you buy. And that's the equation for figuring out the cost of socks, okay? What I'd like you guys to do is, in your own words, please explain right here how using that table is similar to using a double number line and how it is different.